Hello world. Thank you everyone for joining us today. We are going to get started. I still see we have a very large audience, which is fantastic. Today we'll be talking about Python integration with KNIME. In particular, we'll cover topics such as visualization and stable matching. And we're also going to give a slightly more technical look at our Python nodes and our custom Python base nodes. Today, our speakers will be David Plummer. David is a longtime user of KNIME in various roles, is an avid KNIME user who writes really high quality blogs on topics like customer segmentation, plotly themes, and high precision calculation, all with KNIME on his Medium account. He has over 30+ years of experience in business and consulting roles. I am Victor Palacios, and I received my master's degree in data science from the University of San Francisco, and I currently work in the same field at KNIME. I teach courses on data science, machine learning, and of course, KNIME. And my initial projects and interests were in deception detection and also in healthcare. We will be the two speakers for today, and Karsten will be helping us out with the Q&A. So Karsten is our resident software engineer and coordinates making KNIME and Python work together seamlessly. He was tackling bioimaging analysis problems and also building open source software when he was pursuing his PhD in computer science at the University of Heidelberg. This is the first time that he collaborated with KNIME, and so in 2021, he actually became a full-time member of the KNIME team. And so he has volunteered to help us out with our Q&A. So for today, please remember if you have any questions to post them in the Q&A and Karsten will help out. If there are any questions directed specifically to David or to myself, then Karsten will let us know at the end of the session. All right. So the goals for today will be to give you a brief introduction to KNIME for those of you who are just coming over and wanting to see, what exactly is KNIME. Then we will also talk about building custom visualizations using Plotly and KNIME together, and that will be David talking about that. It will come back to me, and I'll talk a little bit more on technically how we use the Python script node, and I'll give an example using stable matching. Afterwards, I'll show you how to create your own Python base node, which is a brand new item that we have in KNIME. So first off, what is KNIME? So the KNIME Analytics Platform is a place where you can, for instance, gather your data together and blend it, as we call it, or put different pieces of data together. For instance, I can draw data from PDFs, from JSON files, from Excel sheets, from Google Sheets, you name it, and most likely I can put it into KNIME and then collect that data and consolidate it. On top of that, I can then visualize it, which is what David is going to show us. I can even perform statistical analysis. Afterwards, I can process that data and check the quality. And if I can do all of this, I should also be able to do, of course, machine learning. I should be able to model and evaluate. And after I've done all of this work, I probably want to share it with the world. So this is also why we can do deployment in KNIME. So the KNIME Analytics Platform is an open source, free, no code, low code tool for the entire data science lifecycle. Now, what does it mean to be low code or no code? This means that we actually take nodes and we drag and drop them into our workspace. So I can have some nodes that have no code and allow me to, for instance, create data and then perform some kind of analysis on that data or manipulation of that data. From there, I can then put that together into a Python script node, which is actually going to be my low code. So you can see here, I can use a combination of no code and low code tools. Now I'm going to let David take it away with visualizations. So David, if you are ready, I'm going to stop sharing my screen.
Thank you, Victor. Can you just confirm that you can see the slides? Is that working?
Yes, thank you.
Excellent. All right. Well, thank you very much, Victor, for that introduction. Welcome to everybody else. I'm going to talk about creating customized visualizations in KNIME using Python nodes. Just a bit of a background for myself. I've been using KNIME for getting on for nearly 10 years now. In that time, I've seen it develop rapidly And to give some idea of why I use KNIME and what I use it for, a lot of the work I do is data analytics and modeling, primarily within the field of healthcare, for hospitals, for healthcare systems, for social care systems. Within the work I do, there are a number of aspects to that. Sometimes I need to produce simulation models, and for those models, I tend to develop them in things like C#, because the models need to run quickly. We might need to run the model or simulation multiple times to evaluate multiple different options. Doing things in C# tends to be quite labor intensive, but it does give us some benefits, as I say, with respect to speed. We've got Python, which we use quite a lot because we've got access to lots of algorithms and lots of latest research and thinking in terms of large language models or in terms of optimization algorithms, machine learning. And then we come to KNIME, which has a lot of strength in terms of ingesting and analyzing data and visualizing it, where the focus of the work and the analysis that we're doing is more about the data and less about the actual modeling. And so it's a lot of the work we do is moving between these three domains. And what's been particularly beneficial is the ability to integrate Python into KNIME so that we have access to a lot more capability, a lot more algorithms within the KNIME environment. That's beneficial because we have people who might not be natural coders, but they want to be able to access the latest techniques. And by building nodes, custom configured nodes in the KNIME environment that reference out to Python, it enables us to enable or give more capability to people to be able to do the analysis themselves without needing to pull in other people to do coding. In terms of the typical process, there's the extracting, transforming, loading data, some analytical processing, and then visualizing, which is what I'm talking about today. Historically, KNIME started out with some Java Swing-based visualization nodes. Those started to develop and become a little bit more sophisticated over time, and there's a couple of steps here in terms of nodes you will see within the KNIME component toolkit. And what I'm talking about today is the Python view nodes. I tend personally to use quite a lot of Python view nodes because the clients I work with have expectations for specific visualizations. And they might be things like population pyramids, where they won't be developed typically as a standard node within the KNIME toolkit. So being able to produce things that are customized, being able to produce things which are branded specifically to the customer is also something which is important for us, so that it's got the look and feel that the customer is actually looking for. In terms of the Python library, I've standardized on Plotly. The reason for using Plotly is that there's a wide selection of charts. It's got interactivity, which means that you can actually zoom in on the data. You can actually, within the interface, click on the chart and download a PNG or a JPEG version of it. It's very customizable. We can develop themes. And also, because we work in an environment where we've got multiple languages that we're using, so we use KNIME and we also use C# and JavaScript. We've got that cross-programming language support within Plotly as well. And then to speed up the development, to make sure we don't spend too long developing, there's Plotly Express, which is an abstraction of Plotly, which makes it far easier to make simple charts very, very quickly. And Plotly Express is what I will concentrate on today. In terms of an example customization, this is typically the sort of chart that I'll produce. This is a population pyramid where you've got age ranges on the y-axis and you've got a 2-axis chart. The right side was showing the number of males, the left side the number of females, and we wanted to show at what stage people were being diagnosed with cancer by age. So we've got stages 1 and 2, which is an early detection, stages 3 and 4, which is later. And it just means that we can actually produce nicely formatted charts that can be used directly in presentations with the customer, and also fits with an overall theme and branding that might be appropriate. Plotly concepts. Plotly itself was originally a JavaScript library, so it runs within the browser. So within KNIME, when you open the visualization, what you're seeing is actually running within a browser type framework. But to create it, you can create it in multiple languages. And here we're using Python to actually create the chart itself. Plotly Express is the overall library I'm going to show you in a second. But beneath that, there are a number of other libraries that allow you to do more sophisticated and more detailed configuration of the charts. What happens is that Python creates two files. One is data, which contains the traces, which are the individual lines or the individual bars or data series in the chart, and a layout description, which describes how the data is to be laid out and how the chart is to be displayed. I'm going to just take you through some of the bits here that enable us to do show the basic chart and then the customized chart as well. This here is a very basic KNIME workflow. So we have some data that have been put into a table creator node, and then I typically create a component so that the visualizations can be configurable. So this one is to produce a very basic stacked bar chart. And here we can see an example of the stacked bar chart that's created. The component itself, we've got configuration nodes. So if I right click on the component, it will give me a dialog box, and I can enter things like the chart title, titles for the X and the value axis, categories for titles, and various other settings saying, which columns contain the data to make it very configurable. So all of those are captured in variables, 9 variables, and those 9 variables are fed into the Python view node along with the table data that has been fed into the component as well. So we now have information to say how we want to display the chart, and we have the data for the chart. So how do we go about writing the Python code that enables us to produce this very basic view we've got here? First thing to bear in mind is Plotly itself is included within the standard KNIME installation, or the standard KNIME Python installation. There's another library that needs to be added, and that is Python Kaleido. That can be installed either with the Conda configuration node, or if you are using a separate Python environment, you can add it using Conda to install that from Conda Forge. I should note that the package Python Kaleido, which enables you to export a static image of the chart if you want to produce static images for the workflow, that package is no longer actively maintained. The person who did maintain it used to work for Plotly, they've left. So if there are problems, you will need to go onto the internet and do some Google searching. There shouldn't be problems. For me, it's worked perfectly fine, but there have been instances where people, for their specific instances, have run into a few problems. You don't definitely need Python Kaleido if you're not producing static image outputs. You only need the Plotly package, but if you are wanting to produce a static image output, then you will need Python Kaleido. In terms of the code, I'm just going to step through the code here and talk through it, just so you've got an idea. We will be sharing a link to the workflow that's actually on KNIME Hub. So if you do want to download it and play with it yourself, you can do. But what I'll do is I'll give you a talk through here, and that will give you an idea of what you'll be looking for. First thing to do is the standard thing in all KNIME nodes is to import the KNIME library. We also need to import the Plotly Express library as well, and to import Plotly IO if we want to do any exporting of static charts. Also, which is common across all KNIME Python nodes, import the data from the port. So we have the data table on port 0, and we need to import that into the import data variable. We then need to also import all of the variables that we use to define the aspects of the chart. So things like the title name, the X column, sorry, the title's down here, and which columns in the data table contains the X data, the value data, and any category data that might exist. So that enables us to capture the data that we need. In terms of actually plotting the bar itself, we create a figure, which is output from Plotly Express, and we use the bar method. We put in the input data, which is the data that's come in from the KNIME data table, and we just specify which column contains the Y values, which column contains the X values, which column contains the category data or the categorized columns, and that's used to color the bars. And then we can also change the labels on each of those axes. So the X column will be the X axis title, the value column will be the value axis title, category column will be the category title. And it's just all very simple in terms of a single method for actually creating the data itself. And that creates the trace, which when I talked about passing data from Python into the JavaScript, which displays the chart, that's the data aspect of it. In terms of the layout, we're using a default layout to display the bar chart, so there's not much to update. What we do want to update is to set the title text to the title. We want to add a title to the legend, and we want to set the bar mode to be relative, so that the bars are all stacked on top of each other. That's all that we need to be able to do to create the figure itself. The final step we need to do is take that figure and present it in the view, and there is a KNIME function specifically for that, which is KNIO view. We pass it figure as the parameter, and we assign it to the output view. And then when you right click on the component and execute the component to calculate and view it, you will see your figure output as shown here. So that's what you will get as your output. Now that's the standard Plotly layout, standard Plotly way of showing things. If you want to customize it, we'll get on to this second. But the other thing you might want to do is that you might want to add an output port, so you can output a static image. You can do that by clicking here or on the 3 ellipses in the swing, or in the version 5, the new interface. You can do by clicking here, and that will allow you to add a object output port. To be able to output, there is another function that you can use, which is PIO to image. Put in the figure that we had before, specify the output format, and in this case we've set PNG, width and height. So here we've got 800 by 600, and then assign it to the output port, and that will allow you to output from the Python view a static image of the chart as well. And you might find that useful to add to the workflow. I've used it in the past to be able to output images, which we then pass to the report writer, and then use the report writer to output PowerPoint slide decks, which contain a number of images that we then provide to the client. The standard format for Plotly is okay. Generally, it conveys the information, but sometimes it's nice to be able to customize the visual to add some branding to it, to show things in a slightly different way, to change the colors, add grid lines. So what we have here is this is another chart that I've created previously. We've added different grid styling. We've added a banner title, so I added a background to the title to make it stand out a little bit more. We've added custom fonts so that it's a little bit easier to read and is more consistent with other branding and documents we produce. Change the background color, so it's a little bit difficult to see, but there's a pale yellow in the background, and customize the colors of the bars in terms of what's shown in the chart. To be able to do that, there's a little bit of a concept. Within the chart, you have what's called the paper, and the paper is where the actual figure will be drawn. And that is indexed from 0 to 1 on the X and 0 to 1 on the Y. So when Plotly is plotting things out, if you plot things at 0.5, 0.5, it would be in the center of the chart. And it is a way of referencing, adding labels, adding bars, adding charts. When you go deeper into the API, you've got a lot more control over where you place things, and it enables you to create custom visuals, change away from some of the standard charts that we're showing here. But I'm not going to go too much into that. I just want to point out that there is a way of referencing things here, because we'll use that in a minute to place the background behind the title. We can also specify things like left and right margins, top and bottom margins. So when the visual is shown, the 800 by 600 in terms of the size of the visual will be the outer yellow box. Take away the top margin, bottom margins, and that will give you the size of the paper that you are plotting your chart on. Because the Plotly visualizations are reactive dynamic, if you resize your windows, then it will maintain the margin sizes and it will shrink the size of the paper. So you do need to think with your visualizations quite carefully about the size you want to show your visuals, how much space you need for your margins so that you can actually display text around the image correctly, and how much space you'll have left in the paper to make the visualization clear. So quite often you might need to think about the minimum size. So you might say, well, the minimum size of my visualization will be 600 by 800. And that will mean that the paper size will be in the range of 480 to 500 pixels, which is enough to display the information clearly. If it gets too small, then the visualizations start to break up, and it becomes a little bit more difficult to communicate the information clearly. So to create a custom template, what we do is we import the Plotly IO API, and we can create a new template. In this case, we'll create a template called KNIME 1, and we can base that by copying a built-in standard template. So we're going to copy the built-in Plotly template, which is the standard template that we used for the previous visual, and has the common layout, common background, standard colors that Plotly uses as a default. So we'll create this new template called KNIME 1. I'm also going to specify some standard colors. So I've got my main color. I've got my font that I tend to use. I like to use, and I've set the background color for the paper, for the plot, and also for the grid lines as well. So by defining them as variables, it means that when I want to use them, I'm not repeating the fixed HTML color codes. I'm just able to reference them with the variable. And if I want to change colors, I can change them at the top of the script here, and it flows through to all the other items that I've defined further on. To update the items in the template, they're all stored in the template as dictionary items. And so it's a question of updating. So the method statement is an update, and we update by passing the template more dictionary items as well. It's easier in this case to use dict rather than the curly braces to define the dictionary, because you don't have to put quotes around each of the dictionary keys. So this is a dictionary key here, which is the layout, because we're updating the layout. And I'm going to pass that a dictionary of things that I want to update. So I want to update the font family to make it the main font, the font color to be the same as the color main, the background colors, the size of fonts, margins around the image, the title, X and Y positions, and various anchors in terms of where I want to anchor the image. So in this case, I want to anchor the image at the top and not at the bottom, so that it expands downwards from the top of the image. Within Plotly, you have a shorthand code. So the color is within a dictionary of font, in dictionary of title. So normally you would specify that in Python by specifying title, curly braces, and then the key, and then another key to set the actual value. You can use chaining to actually reduce the number of items that you need to provide. So you can go title, font, color, and that is a shorthand for this dictionary structure that you would typically use in Python. Here we've got a number of parameters that we've set that set the layout that we want to use. I can also set the sequence of colors. So that would be the same update, but this time we're updating the colorway, which is the colors that we want to use. And so the first data trace would be allocated the first color, second one, the second color, and that allows you to set some standards across various visuals. We can update the x-axis and we can update the y-axis. What I've done on the y-axis to be able to put my title at the top and have a banner behind it, I've actually reduced the size of the paper by 5% in this particular case. And what that's done is it's given me a bit of space at the top of the chart, between the top of the chart and the banner itself. And we can also then specify by updating the layout, adding a shape behind the title. So in this case, I've added a purple bar, purple rectangle. And to do that, we say that it's 1% above the paper, up to 30% above, and it's extending outside the bounds of the display area. And that allows us to have a nice background to the title here as well. The final thing we need to do is that once we've updated the template, we then need to set the template, the default in Plotly to be the template that we've created. And then once we've set the default, that will then be applied to the visual itself. And we'll get the visual that I showed at the start in terms of what we've got. What you can also do is you can create a custom component here, and we can pass from that custom component into other visualization components that we've created. In this case, I've created a nice little dialog box that allows the theme to be changed. It allows us to show the banner or not show the banner. It allows us to change the font and standard output sizes. That then feeds across into the individual visualizations. And so we've got consistent theming across each of the visualizations that we might want to show if we're putting them all into a dashboard, and we want to make sure that everything's consistent. The advantage of doing this is that if I want to make changes to the visualization theme, I just have to do that in the component. I don't have to do it in each individual visualization. To give you an idea of how to do that, this is the theme component and the components here. So we have the same widget inputs, which are converted into variables, fed into a Python script. Out of the Python script, we can pass serialized data, which is pickling within the Python terminology, and that converts data which can be picked up and passed into the Python view node. So here we've got pickled data passing through a pickled node into Python view. To be able to do that, we can't actually pass code directly from one component to another. So what we have to do is store the code in a string. So here I've created a string called theme code and built up the code as a string within the theme component. That string is then output on the pickled node, and the data is then passed into the visualization component. It's picked up from the pickled node, pickled input node, and then we execute the string. And executing the string is the same as having that code within the visualization component. So it's a way of replicating data across a number of nodes and having one location to actually update the code itself and update it in and execute it in several target components. One thing I just point out, because we're executing arbitrary code within Python, you do have to trust the code that you're executing. So it is possible, if you're not careful, for somebody to inject code into your script. If you then execute it, there is a security risk. So do make sure that the code that you are executing is code that you are validating and you're sure that nobody's been able to tamper with it. In terms of further information, there's the KNIME documentation, which is on Python installation guides, and there's useful information on the KNIME API, which is a little bit more detailed. In terms of Plotly, there's the Plotly Python website, which provides plenty of examples and shows you how to plot different charts. And there's also the Python API reference, which is very useful when looking for specific attributes in the dictionaries that need to be updated to produce specific outputs. That's just been a very, very quick overview. The idea is to give you some idea of how to approach the problem. And if anybody's got any questions, I'll be quite happy to answer them. Victor.
Thank you, David. Okay. So next up, I will be presenting. Okay, so David focused on the Python view node, and I'm going to focus a little bit more on the Python script node and also on custom Python base nodes, which look and feel like native KNIME nodes, but they have a Python backend. So let's get started with that. So I'm going to talk about these things through a problem, which is stable matching. So first off, let me explain that. For instance, I might have an organization restructuring, and I now need to assign new team leads to different employees. And of course, each team lead will have their own capacity. So this team leader, for instance, will only be able to pick up 2 employees, and this team leader will only be able to pick up 1 employee. As well, the team leads will, of course, have preferences for who they want on their team, and the employees will also have preferences for who they want to work under. So you can imagine that it looks something like this, where this team lead has a certain preference, and this team lead has a certain preference, and also the reverse. So of course, as an organization, we want to maximize productivity and, of course, employee and leader happiness. So it would be fantastic if I could take this task, which is a matching task, which can take quite a bit of time. Personally, I've done this with much larger numbers of leads and employees, and this can take hours or days, depending on how you're doing it. And so we want to turn that into, a seconds task. So I would like to have an algorithm that can solve this problem for me and maximize the happiness of my team members. Now, there are actually several kinds of matching problems. The one I just showed is typically called the hospital resident assignment problem, in which we have 3 entities: the organization capacity, and the applicants. So in my case, I treat organization as team leads, of course, their capacities, and the applicants as the employees. But there are other problems that you might encounter. So not an HR problem, but perhaps a dating problem or a rental agreement. So for instance, in stable marriage, I have 2 distinct sets of people that can only be matched to one other set of people. In stable roommates, I actually can match any person with any other person, so long as they have a preference for one another. And in the student allocation problem, I have actually a slightly more complex version of the hospital resident problem. Here I have the instructor, for instance, at the bottom. Then each instructor has their own projects. And now each of those projects have their own capacity, with which students will need to be matched with. So depending on the problem that you're trying to solve, if you have a matching problem, which I assume almost all organizations will have, then you might need to choose between these different matching algorithms and use the one that's appropriate for your problem. So let's get back to our particular problem, which is the first one. So what we want is a optimally matched lead and employee matchup given some capacity constraints. So at the end of the day, this is a kind of outcome that I would like to get. Now to do this, what I did was set up a collection using a Google form. So I went ahead and asked the team leaders, what is your preference? And then I also asked the employees, who would you like to be led by? So I did all this in a Google form. And then I took that data and I put it into KNIME using the table creator, which is similar to what David had presented to us earlier. Afterwards, I did some data manipulation and then pushed that into the Python script node. So if you just download KNIME, you will notice that you don't have access to this node or anything for the Conda environment. So for instance, out of the box here, I go to Preferences and I don't see anything for Python. So to get it Python, I must drag and drop the extension from the KNIME Hub into the workbench, or I can install it manually. Either way is fine. But you will need to download this first in order to use the Python script that I'm about to show you. Now, once we have downloaded this extension, which kind of acts as, for instance, an app on a phone. So you download it, you buy your phone, and then it only has a certain number of apps. And so you need to add more apps. And so KNIME calls these extensions. So I get my Python extension. I notice now I have a Python tab, and I have several different environments that I can choose from. So in the newer versions of KNIME, we actually have a bundled environment. And this comes with packages like Beautiful Soup, Pandas, Plotly, just like David was showing you, and so on. Now, in my case, I actually want to use this matching library, but I check here and I notice, okay, I don't actually see that library. So I'm going to have to use my own environment. So instead, I'm going to click on Conda. And then here, it's going to show me, for instance, the several environments that I have available to me. So I'll choose stable matching. Now, in order to create this stable matching, what I did was click on New Environment, and I allowed KNIME to create this environment for me. I did that because then it will give me full compatibility with KNIME and Python, and I don't have to worry about any dependency issues. Afterwards, I did pip install matching, and I was able to get my algorithm to work. So now that we have everything set up and we're ready to go with our Python script node, I double click it, and I am shown just a few lines of code. So I add my own code in here, and then I am able to get it running. Now, if you're brand new to the Python KNIME integration, the main things that you need to be aware of, and some of which David has shown you, is that you need the KNIME.scripting.io, which typically we shorten as Neo. And then you need to convert your KNIME tables into Python data frames. And that is how we typically deal with the data in these Python script nodes. Finally, when you output your data, at least in the Python script node for a table, I need to convert the data frame to a table. So this is the most important thing here. You are initially setting up a table, you transform it into a data frame, and then you reverse that process in order to get your output, and then do further data manipulation or any other processes that you need to handle. Now, the advantages of this are that it's easy to debug and maintain because the code is right there. It's also easy to explain because you can just walk someone through this. And of course, you can make changes on the fly, or you can allow others to make changes to your script. Now, that might actually be a disadvantage for you, depending on what exactly you're trying to do. So let's talk about other ways we can use Python code in the KNIME Analytics platform. So we can actually create our own custom Python-based nodes, which really mimic the original KNIME nodes, right? This looks a little bit like an original one, right? It looks a little bit like this partitioning node here. It doesn't say Python or anything on it, even though the backend is all Python. So this will allow me to write a complex Python script or even scripts that are located outside of KNIME. And this will protect if, for instance, you do not want people to be able to manipulate your Python scripts. So that's one advantage here that we see. So you can see here that I will build this separately in, for instance, Visual Studio Code, and then it will be able to work in KNIME as if it was a native KNIME node. So how do we create these custom Python-based nodes? So there are three primary steps. The first is that we will need to install Necessities. We'll need to establish a connection between the KNIME Analytics platform and these external scripts. And then we'll need to write Python KNIME specific code. So the necessities that we'll need are KNIME. We will need the KNIME Analytics platform version 4.6 or higher. You will also need another extension. This one is for the Python node development. And you will need some form of conda. Finally, you'll download the basic folder, which will give you a template for how you will go ahead and build out your own node. So in the basic folder, there are many different items. For instance, in the tutorial extension, you can find the myextension.py, which will actually be the script that you'll be using, and that will connect with your KNIME node. Now, to establish a connection between KNIME and Python, we will need to change two files, which are the knime.ini file and the config.yml file. And this is basically just giving them paths, letting them know where these different things exist. Now, of course, we are going to share all of these slides with you after the fact, so I won't go into too many details here, but these are the main things that we need to configure. So to confirm if it worked or not, we will restart the KNIME Analytics platform, bring it back up, and we will see, for instance, my template. And it has this wrench image, and the node itself is called my template. I can then drag and drop it into the KNIME Analytics platform, but I notice it doesn't have any functionality. So now we actually have to code that up. So there are three things that we have to tackle when coding. For the coding, of course, we have to work on the aesthetics. And this is a class in Python. So before the class, we have some decorators, which are very nicely named because this is actually what they do. They decorate. So I will do @next.node, and for instance, I can add a title. Then I can add inputs and outputs that I desire here. I can even add an image to this node if I want to. Now, when a user clicks on my node, they're going to be presented with some options. So here we can say we use some parameter, so next.int parameter or next.double parameter, and this gives the user some options to choose. For instance, which column are we going to be analyzing? Or how many hidden channels do we have in this neural network? Or what is the learning rate? And finally, we have the functionality. So for functionality, there are two primary functions, which are configure and execute. Configure allows us to define specifications and rules. So for instance, we can say something like, if the user passes a table to this node, which doesn't have a string, throw an error. And execute, we then actually perform the operation. So this is very much like our Python script nodes or our Python view nodes, where they're performing some operation. In this case, I'm training a neural network. So now that we have a basic understanding of the Python script node and also the custom Python base nodes, I like to compare them. So for the script node, it's easier to use for beginners and can help with prototyping. That's how I tend to use it. For the custom nodes, these allow for more control and modularity. Like I said earlier, the user can click on this node and they will get some choices for dialog, but they will not be exposed to the Python code itself, which can help when your Python code is quite complex and you're worried that users might do something that then breaks that code. On the other hand, we also have versioning and collaboration fit for your company. So some companies really want to work with Visual Studio Code, or they really want to collaborate on GitHub, and they want to use the scripts that they've already written. And so in that case, you might be able to use these and then collaborate with many people on the tools that you prefer to use. Now for resources, just as a reminder, this must work on the KNIME Analytics Platform 4.6 or higher. And the resources that come with this are a blog, documentation, and we even have two examples, one in which we calculate geodistances and one in which we create a graph neural network. Now, in summary of today's talk, you learned how to build custom visualizations with Plotme and Lime, how to use our Python script nodes, and of course, our Python view nodes, and how to build custom Python-based nodes. For further KNIME-related links, I really recommend the forum where you can ask questions and get answers from the community or even from KNIME team members. I also recommend the workflows repo, which is hub.knime.com, where you can download other people's workflows. And of course, there are other various things that you can check out. One of my favorites is YouTube for seeing live demonstrations of how to use nodes. So thank you so much. We are now going to open up the chat for questions. And so Carson, if you can let us know if there are any questions that we should tackle first. Thanks, everyone.
Hi there. Yeah, there were a bunch of questions, and I guess I might address one of them, which was asked a bunch of times, namely for this bundled Python environment. People are apparently happy to use the bundled environment that we provide when you install KNIME with the Python integration, but they want to add more packages to it. And right now, this bundled environment is not extensible, meaning it will be the same for all users, which has the benefit if you use the bundled environment, build a workflow that uses those Python packages in your script, send that workflow to somebody else who also uses the bundled environment, that should work out of the box without somebody having, somebody tinkering with that environment. However, as soon as you want to change the packages that are contained, you would have to create a new Conda environment, so a Python environment yourself, and use that in your nodes. And if you want to share your workflow with the special requirements, then we have a special node for that. It's the Conda environment propagation node that allows you to capture the state of your Python environment, and then that will be recreated on the machine of the other users using your workflow. Okay, with that out of the way, there was one question that I would, well, no, actually, there were two questions that I would hand over to David. There was one, there was, while you were talking about the different, well, styling the visualizations, somebody asked whether the font families have to be installed locally. Do you know?
Yeah, the fonts have to be on the client computer. So I have looked at whether they could be pulled in using cascading style sheets or HTML code. I mean, Carsten, you probably are more familiar than I am with the internals of KNIME, but I haven't yet sussed out a way of actually doing that. So they would have to be on the client computer, and that is, you know, if you're using the server version, it's not on the server because that wouldn't work. It has to be the client's machine, so you'd have to distribute them out to all of the end users, which is why typically you end up using sans serif or serif fonts as your defaults, because then you're not tied to any specific implementation. I have tended to specify my own fonts because in many instances I'm producing PowerPoint outputs, and so therefore I've got more control over what fonts are installed on my machine and what gets embedded into PDF output from the PDFs, from the PowerPoints.
Maybe at some point we can, David, we can try this together, because there is a, maybe you've tried already, there is a data area in each workflow. So you can place files in a workflow, and I think with the latest, since KNIME 4.7, you can access this folder. You have this path available in the Python API in this KNIME.io interface, and then you can maybe find files there, so you can basically include them in the workflow.
Are you setting me a challenge for this week? Is this the KNIME challenge for the week to see if we can access fonts in the data folder?
Yeah, I mean, that would at least allow you to also run this on the server if it works with.
Yeah, no, it's a good approach, and I'll see if I can give it a go and post something in the forum, because it would actually be, I think, quite useful in terms of giving us a bit more flexibility.
I guess so, yeah. Okay, one other question that I found very interesting, and it's also probably something where David and I can ping pong a little bit. The question was, for Python visualizations, is it possible to link it with KNIME widgets for interactivity, like the interactive range slider widget, or to create your own range slider that appears in the component along the visualization? And I don't know whether you've tried that with Plotly.
Yeah, I put an answer in the Q&A session, actually. So yeah, I mean, in terms of live updates, Plotly allows you to zoom in on the charts because it's interactive. You have a zoom capability, and you don't have to do custom visualizations because KNIME already has some Plotly visualizations that you can actually experience this with. So if, for instance, I've used 5-year time series data, but it's been with a daily resolution, and so I've been able to see the overall chart showing the 5 years and zoom in to a particular day that I want to look at in more detail. So that's one of the reasons for using Plotly, is that ability to zoom in and out of the data to get more detail. Within the chat, I also posted a link to a Python visualization that has a slider that sits below the visualization, so you can actually constrain the data and constrain what's shown, and that's quite useful, and that's another way to actually add a slider capability to the visualization. And then the final way is if you want to use Python, KNIME widgets within your component, you can do that, but you'd have to manually re-trigger the Python visualization to get it to update and redraw. So
Exactly,
that gives you a number of ways of tackling the problem.
And in general, that's maybe something I think you mentioned that, or well, it was more of a side note. The Python visualization, as soon as the node is executed, you have to have all the data available at the moment. So this view itself, after the node has been executed, the data needs to be static. But whatever happens in this, well, Plotly visualization, you can change the ranges of data that is displayed. However, if you really want to, and that's exactly why with the KNIME widget you need to re-execute the component. If you use the KNIME widgets, they actually feed input data into this view node, and then you need to re-execute, and that can provide another view, and then you can actually change the range of the data, or select a different column or something like that. Yeah. Yes, so apart from that, we did have a bunch of other questions that were already answered. Here's another nice one, whether you can actually get the code in a Python script node from Git. This is something that users have been requesting multiple times, and we do have Git nodes in KNIME, but with those you can pull your Git repository, but you would have to import these files into your script node and then use them from there. So directly in the script node, we don't have that functionality at the moment, even though being a developer, fully understand why that would be nice.
There was a question, Carsten, about is there a gentler introduction to Python visualizations? I did go through the presentation very quickly, and the purpose for that is to give everybody an overview, and because we're sending out the slides, and there'll be a workflow that goes with that as well, gives people an opportunity to investigate and look into those the presentation and the workflow itself to learn. And I wanted to give a rapid overview with some pointers. But if you want something that's a bit easier to do, then on the KNIME website, there's some really good tutorials and walkthroughs that give a bit more background, and maybe is a simpler stepping stone than diving into the presentation, which some people pointed out is a bit more advanced than people are quite ready for at this stage.
That's true, and I also replied in one of the other questions that we do have a Python script space of workflows on the KNIME Hub, which contains a lot of examples that are not super advanced and help you get started with visualizations, but also with all the other cool things you can do with Python script nodes. Good point, David. Yeah.
And there's another one saying, apart from Plotly, which other interactive visual packages can display visuals like Tableau? Then, the Plotly view node also supports Matplotlib, Seaborn. There's a couple of, I forget what the network charting one is that you support in there. So there's a whole range of Python libraries that can be used within the visualization node. which gives a lot of flexibility in terms of, you know, the types of data you can show and how you can visualize it.
Exactly. Yeah, where Plotly is just a very famous library for doing nice interactive plots, and that's why we've been focusing on that, or you've been focusing on that. And I think it's the most used one, but you can use, in theory, anything that outputs an HTML page at the end. Okay. So
some other questions that we got, for instance, was, can you use Google Colab as a Python platform to integrate with KNIME?
well, the question is how, well, KNIME doesn't usually send, well, Google Colab, the beauty of that is that your Python or your interactive notebooks are running on the servers provided by Google. So what we do have is an IPython notebook integration where you can use your locally stored IPython notebook and execute that from within the Python script node, but that still means everything is running on your machine locally. What we don't have is to have the KNIME Python script node ask Google Colab to run a workflow or run the script in your Python script node, for instance, or to actually execute some notebook that you have stored there. No, at the moment, that's not the case.
Right. And then there was, I think, a question directed for me, which is for the, or maybe Carson, if you'd like to answer, but for the Python custom nodes, did I understand correctly that you can define the node input parameters with code? And this is a yes, right? Everything that we can do with the custom Python nodes is codable.
Exactly. So that's the beauty of the Python nodes. They do have very few, so it's not a lot of boilerplate you have to write, very expressive. And you define the input and output ports of your nodes, as well as the parameters that will show up in the dialog, everything in code. And yeah, makes it very, so we've been using that internally now a lot, and it's actually really nice to sketch a node very quickly, sketch down a node very quickly. And just if you're a Java developer, pitching this out here, we're working on having this this kind of an expressive API for writing Java KNIME nodes too.
Yeah. And then someone is talking about server. They're saying that I think they're talking about the Python custom nodes not working on server. Is that something that we are actively developing or have a timeline when that will work?
No, I think that discussion was from, it was a longer discussion. So the Python nodes do work on server. The thing is that you need to, independent of the pure Python nodes that you develop, when you want to your Conda environment to also be created on the server. That's, I think that was where this question was coming from. Then the best thing to usually do is to use this Conda environment propagation node. And we have a blog post on that explaining how to use that best. And also just the most important point here that I guess I would like to make is that there is a button saying include explicitly installed packages only, which makes it usually work across operating systems. Because if you have some Windows specific libraries included in the environment and you want this to run on a Linux server, then it will obviously not manage to install those Windows dependencies.
Okay, so we actually have reached the point on the hour. So what we're going to do is take these Q&A that remain and migrate them hopefully over to our KNIME forum. Or if you're interested in getting an answer a little bit sooner, you can go ahead and post them on the KNIME forum link that we shared in the chat. And then we will get to them and answer them for whoever they correspond to. So thank you everybody for joining us. We look forward to seeing your questions and having more discussion on the KNIME forum. Thanks everybody for coming.